Hello class, today we're going to talk about surface area of a sphere. Okay? Now we are going to do a warm-up today, but we're not going to do the warm-up through this video. So I'm going to skip through that and go on to the lesson slides. Okay, so the first question I have for you, is there anyone that would need to know how to find the surface area of a sphere? Who? Why? Well, there are people out there that actually do need to know how to find the surface area of a sphere. Most of those are in the sports activities, in the sports realm, because when you think about making a baseball or making a basketball, you have to know how to make the covering for that particular shape, okay? And that is nothing but the surface area of a sphere. Okay, so let's take a look at that. So to find the surface area of a sphere, how would I do that? Well, if we were to look at this particular shape right here that I'm going to pull up, it is that of a baseball. It says a baseball is a good visualization for realizing the formula for the surface area of a sphere. The baseball's cover can be cut off and laid out as it is below. The parts of the cover approximate circles. It can be seen then that the surface area of this baseball would be the sum of all four circles. So if we were to look at this particular shape, let me make it a little bit bigger. You'll notice that we've got a circle right here. Now, let me get my pen back. We've got a circle right here. We've got a circle right here. We've got a circle right here. And we've got a circle right here. Now this part here in the middle is actually an overlap. Okay, so it's overlapping those particular circles. So we wouldn't actually include that particular one right there. Right? See if I can get rid of all that stuff there. Right? So really, in order to do the surface area of a circle, we have a formula of 4 pi r squared, because we've got this circle, this circle, this circle, and this circle, which would actually represent the surface area of that sphere. Okay? So that's how we would actually do that. So what is our formula for surface area of a sphere? Let's see if I can get this, see if I can remove this real quick and move this back down the way we need it to be. Okay. Let me see if I can get rid of this real quick. So what is our formula for surface area of a sphere? Well, the formula is nothing but S equals 4 pi r squared. Now I'm going to put a video on Google Classroom that'll kind of demonstrate this, because there is an activity that you can do that could help you determine what the formula really is. And it'll kind of show that. So this is our formula. Okay, so let's see if we can actually use that. So here's a basketball. It says, how much leather would you need in order to make this basketball? Well, what we would do is we'd write our formula. Okay, S equals 4 pi r squared. So all I need is I need pi and I need the radius. Okay, so S equals 4 times 3.14 times, and if you look down here, it says our diameter is 9.5. So that means we take our calculator and we type in 9.5 divided by 2, and you find out that the radius is equal to 4.75. So to find the surface area, we do 4 times 3.14 times 4.75 times 4.75, and then you go to your calculator and you type that in. So 4 times 3.14 times 4.75 times 4.75, enter, and you find out that the answer is 283.385. Now, if I asked you to round that to the nearest tenth, it would just be 283 point, we look at the 8, it's going to bump the 3 to a 4, and then it's going to be inches squared. So in order to make a regulation style basketball, or regulation size basketball, you're going to need 283.4 square inches of leather to be able to put it all together. Okay, so let's do one more. Let's kind of look at the biggest sphere that we know of, and that is the Earth. So it says, find the surface area of the Earth. So if we know that the radius, the radius is 3,960 miles, we can now find the surface area of the Earth. So again, S is equal to 4 pi r squared. So S is equal to 4 times 3.14 times the radius squared, which is 3,960 times 3,960. Then we go to our calculator and we type that in. So 4 times 3.14 times 3960 times 3960, enter, and you end up with a rather large number, 196,960,896. Oh, and I just wrote a 3. 896. And that would be, looking at our label, miles squared. Okay, so what is that? 196,960,896 square miles. That's a pretty good sized sphere. Now, if we were to look at this last question, it's kind of an interesting thing. It says about 70% of the Earth's surface is water. So how many square miles would be water? Well, we know that in order to find a percentage of something, we're going to take this number right here, and we're just going to multiply by the decimal value of that percentage, which is 0.70 or 0.7. So if we were to take that big old long number and just multiply, if we were to take that big old long number and multiply it by 0.7, we would find out the amount of surface is actually water of the Earth. So I've already got that answer on my calculator, so times 0.7. We find out that the amount of water is equal to 137,872,627.2 miles squared of water. Okay, so you look at that, and that's 70%. So that means only 30% is actually land, which is the part that we live on. Okay, unless you live on a houseboat, and then you live on the water. Okay, so that's how we deal with surface area. So what you're going to do today for an assignment is surface area of a sphere. So let me go down to that. Okay, and so here is our assignment. Now this assignment's going to look very similar because we've already worked this particular assignment, but we used it for volume instead of surface area. So you're going to do the same thing, but you're going to find surface area of each of these spheres. So what I would expect is, 1, write the formula, 4 pi r squared, plug in your values, and then come up with an answer with its appropriate label for that particular sphere. Okay, so you'll do 1, 2, 3, 4, and then of course, the same grain storage tank. I want you to find out the surface area of this one. Now notice the instruction says do not include the base of the cylinder. Okay, so we're not including this part down here. Okay, so with that in mind, I'll talk to you later.